Hi there, I'm Matt Little. I'm going to be doing a presentation here. I've called it the interesting title of Electrical Systems for Renewable Energy Projects. So basically it's going to be a relatively practical session where we're going to discuss various aspects related to all types of renewable energy projects, specifically electricity generators, and we're going to try out a few things. I'm going to start off relatively basic and cover quite a wide range of topics. Just to give you a bit of background, this is based upon a presentation I give for the MSc course at CREST, the Centre for Renewable Energy Systems Technology, which is part of Loughborough University. This presentation is nothing to do with Loughborough University, and I'm a technician there, but I'm not really employed by them. I just use the background, so don't complain to Loughborough University if this is a terrible presentation. Complain to me. That's my email if you want to contact me. What's my background? I've been involved in renewable energy projects for about 10 years. I'm an electronic engineer. I first of all did the MSc course at CREST. I've been working on solar power systems before that at my previous university, which was Loughborough College. And I then did a PhD in off-grid renewable energy systems, so medium-sized standalone power supply systems based upon wind, solar and hydro. And we had this crazily complicated project which had a hydrogen storage system, it had fuel cells, it had high voltage DC being moved around, it had crazy batteries made from a weird technology, high temperature batteries, and it was a bit over the top really, and obviously it didn't work very well. Anyway, still got a PhD, it's fine. And then I realised that I've been working on standalone power supply systems. I realised that I've never actually lived without electricity, ever, for any length of time. So I then found out about Engineers Without Borders, and within about a month of finding out about them, I'd got a placement to go to work with an NGO in the Philippines called SIBAT, Sibol Nan Agham at Teknolohiya, which is the wellspring of science and technology. And I worked there for a year, paid for by Engineers Without Borders, sponsored by Engineers Without Borders. And in that year I worked on off-grid systems, mainly micro-hydro, also small wind turbines. So this wind turbine here, very, very, very similar. 1 kilowatt one, or 500 watts?
We're debating as to whether it was 500 watts or 700 watts.
Right, okay, I think he's upgraded. The same thing, yeah, okay, yeah. It does look like the 1 kilowatt one just starts to become unwieldy.
Yeah.
We were looking at installing 500 watt and 1 kilowatt rated wind turbines in the Philippines with varying amounts of success. We installed 3, I think, so far, but one of them blew down in a hurricane, a typhoon, which is an issue. So yeah, also looking at this exact same design wind turbine, and also looking at off-grid solar photovoltaic powered water pumping systems. So anyway, that's now what am I? Now I'm a self-employed renewable energy engineer. I teach electricians how to install solar photovoltaic systems and domestic solar photovoltaic systems at the Centre for Alternative Technology. Teach at CREST, I'm a technician at CREST, I work on their Applied Photovoltaics group. I'm also work on my own on some pedal-powered stuff, which is generally for fun rather than for any kind of real monetary value. And I'm also working on power and energy monitors for renewable energy systems. So that's what I do nowadays. Based in Nottingham, come from Nottingham today. Anyway, that's background. So what we're going to do, first of all, we're going to look at, I didn't really know the levels of everyone here, I didn't know the backgrounds of what everyone's doing. So we're going to start with very basics of electricity. We need to know these various terms. I'm going to use them and hope that you know them. Hopefully you know a bit already, but we will just go through them. We're also going to go through how to use a multimeter. I think some of these multimeters are broken because of not knowing how to use a multimeter, so we might find that some of them aren't working quite right, so we have to then try some things. I'm also going to go through a little bit of electrical safety. What you're working with today is all low voltage stuff, so not an issue, but you are using batteries which can give high currents and cause flashes and bangs and maybe burns if you really try hard, but don't try hard. Yeah, it's going to be relatively practical. I haven't really tried it in this format, so when I did this presentation before it was relatively structured. So I want it relatively informal, and so if anyone's got any questions, just kind of shout them out. I may be answering those questions later, so I may say, well, I'll talk about that later. So I may say, I'm not going to answer your question quite now. I'm hoping that everyone has the basics of electricity. The things you really need to know about are voltage, current and resistance, and power and energy. So, does this make any sense to you, this kind of circuit? How's it looking? Okay, what we're going to do, Ohm's Law dictates to us that this kind of works. This is, I only need, in my whole career, I've only ever really learned 2 equations. One of them is Ohm's Law, which is voltage equals current times resistance. And also, I actually don't know whose law it is, but power equals voltage times current. That's the other one, which we'll come on to on the next slide. They're the 2 things I always start with whenever I'm doing a calculation. There's the water analogy people may have heard about. Basically, voltage is the same as the head in a water-based system, so the distance through which the water can fall. Current is the amount of water that actually flows, and resistance is the pipe size or any constriction in the pipe. So that's an analogy if you want to know a bit more about it. I don't really like the water analogy, but it's quite a good way of visualising. So what we're going to do first is we're all going to get the multimeters out, and we're going to, so you should all have one of these beautiful, relatively cheap multimeters. And what I want you to do is measure the voltage of the battery that you should have on the table. So everyone kind of know what we're going to do. So say we didn't have it plugged in, which some of you don't. Which wires do we have to plug it in? We want to measure voltage. So we need, first of all, we need to put the black is called it's the common or the negative. And it's common to everything, so we put the black into the black. And then we're measuring voltage. And it's always a little bit confusing on multimeters where you actually need to put your reading. Sometimes you nearly always need to put it in a different socket, depending on whether you're measuring voltage or current. So you actually need to put it in the one that's marked. It says V, ohms, and milliamps. So you need to put it in that one, voltage. And then we want to set it to measure, we're expecting, does anyone know what we're expecting the voltage to be?
12 volts.
12 volts, yes. We're expecting it to be 12 volts, so what range would we put the multimeter on?
20.
Yeah, 20. But we're also looking at 20 volts DC. So that line where it's V and then there's a straight line, that means direct current. And if it's a wiggly line, it means alternating current, AC. I haven't explained all those terms, but you know.
On the denominations of the multimeter, why does it go up in funny units? Why doesn't it go up in like 10 microvolts there?
Because of Mr. Manufacturer, there's probably a reason for it. In actual fact, I do know the reason. 20 volts is actually useful to measure 12 volt systems because you're measuring between about 10 and 16 volts. So actually that range is a very useful range. If you had 10 then 20 then 30, that would be not very, be a bit annoying. There are many reasons for it. If you go, these are very cheap multimeters. If you go up a stage to a slightly more expensive one, you get auto-ranging multimeters. So this one here, you don't need to decide whether it's DC voltage or AC voltage. You don't need to decide a range. It will automatically range the multimeter to either DC or AC. And also whichever, so it'll work at 2 volts, it'll work at 200 volts. And I'd suggest if you're buying a multimeter, buy one that's auto-ranging. It sometimes throws you off a bit though, because it can also, can give you a reading very low, and it says millivolts next to it, so it can sometimes be a bit annoying. And if you want to buy a nice multimeter, this one's a bit broken, but decent multimeters like Fluke, this is a very good multimeter, has lasted me very well. I would recommend buying Fluke, very good. But they're also, that's about 150 quid, so quite new. Right, okay, so has everyone measured their voltages of the battery? Right, that's the issue.
12.3.